Today we're going to work on this worksheet that I gave you the other day. So this should be in your binder. So if you need to pause this video so that everyone can have a moment to take this out, that might be needed. But we're going to work on this worksheet today. And so what this is binary compound nomenclature. So lots of big words here. So basically if we break it down, binary means two. Compounds is whenever we have two or more elements bound together. And then nomenclature is just a fancy way of saying rules for naming. So basically, we're learning the rules for naming compounds with just two elements in the compound. So it's actually pretty simple if we really look at it. And I'm going to go ahead and give you all the rules, and hopefully you find it simple as well. We will work with binary compounds as well as ternary compounds. So we're going to start off with something easy, and when I return, we'll make it a little bit more challenging. So for binary compounds, I'm going to go ahead and give you all the rules. And so we're just going to squeeze in at the top because it looks like we've got some room here. All right. So the first step for naming these ionic compounds, because again, you can't go around saying like, oh, MgS or KBr. They've got specific names that follow specific rules. And so for the first step, what you're going to do is you're going to name the metal. So go ahead and write this down on your paper as well. We'll name the metal, so we can use something like NaCl as our example. So our metal in NaCl would be our sodium. So first thing I would say is sodium. Rule number 2 is we would name the nonmetal. Name the nonmetal. And so in this case, with NaCl, Cl is our nonmetal, and so that is chlorine. So far we've got sodium and chlorine. And finally, the last step is you're going to drop the ending and you're going to replace it with the suffix I, D, and E. So in the end, this compound is not NaCl. If you were to refer to it in a scientific setting, it would be classified as sodium chloride. So sodium chloride. And so what I'm going to have y'all do is in this first column here is I'm going to have y'all practice that. So that way you are used to following these rules for writing the names of these atoms. And keep in mind, these are the rules only for page 1. So for binary compounds that have single charge cations. All right. And so this rule does not apply to pages 2, 3, or 4. This only applies to page 1. So I'll do a few with y'all and you will do the rest in class today. So for number 1, we have MgS. So rule 1 was to name the metal. And in this case, our metal is magnesium. So I will write down magnesium. Oh, I don't know why I wrote that, magnesium. Oopsies. And our nonmetal is sulfur. So we know that we need to name the nonmetal and then drop the ending and change it to IDE. So we wouldn't write down sulfur, we would write sulfide. Okay, so our final name for this ionic compound would be magnesium, sulfide. Can't spell today. I'll do number 2 with y'all, and then you'll do the rest on your own. So for number 2, we have KBr. So we know K is our metal, so first step is name the metal. So we have potassium. And the next step is to name the nonmetal and drop the ending with IDE. So we've got bromine, but instead of writing down bromine, I'm going to write down bromide. It's that simple. Okay, so again, when I return Monday, I'll make it just a little bit more challenging. On the other side, however, okay, now instead of writing the name, I'm going to give you the name, but now your job is to write the formula. So this is where oxidation numbers become very important. So you have a colored periodic table that I had y'all do for homework probably about 2 weeks ago. If you still have that, that may be something useful to use. So again, I'll do a few with y'all here, and you're expected to do the rest on your own. So number 11, we've got magnesium oxide. We know magnesium is Mg, so I'm going to go ahead and write Mg above, so feel free to write that as well. Oxide, we can go ahead and assume based off the, if we were to remove the suffix, this would probably be oxygen. So we have Mg and O. Mg, we have to figure out what, so to write the formula, we have to figure out what the oxidation number is and possibly use the crisscross method. So Mg is magnesium, and we should know by now that magnesium wants to lose 2 electrons. So if it's losing 2 electrons, that is a +2. Oxygen, however, we should know by now, wants to gain 2 electrons. So we can write -2. So in this case, if they have this, if they both have the same number for oxidation numbers, so again, we're not looking at the charge, just the number. If the numbers for the oxidation numbers are the same, you do not need to use the crisscross method. You can, in fact, just cancel them out like they don't exist. So in this case, our compound would be MgNO. That's it. You're done. And remember, when we write the formula, the metal always goes first, then it's the nonmetal. So we'll try one more together and then have you do the rest on your own. So number 12 is lithium bromide. Lithium is Li on the periodic table. Bromide, if we remove the suffix, we can assume that it is bromine, so Br. Lithium, we know that this is a cation, so it's going to want to lose electrons. Based off where it's located on the periodic table, it would lose 1 electron. So I'm going to put +1. And again, you don't have to write the 1, but sometimes I like to write the 1 in case I need to use the crisscross method. And then bromine is Br. And we know bromine is it's an anion. So, the lights just went out. Bromine is an anion that will want to gain 1 electron. So if it gains 1 electron, we'll put -1 to signify that. And again, you don't have to write the 1 if you don't like, but it helps with the crisscross method. And so in this case, our oxidation numbers are the same. So realistically, we don't really need to use the crisscross method. We can just write it out. So LiBr would be your formula. So let's do the next one. Let's just do one more. Sorry about that, because I want to show you one where we do need the crisscross method. You have calcium nitride. Calcium we know is Ca, or you should know by now it's Ca on the periodic table. Nitride, if we remove the IDE, we can assume this is probably nitrogen. So we have Ca and N. And so Ca, we should know by now that it is a cation that wants to lose 2 electrons, so we can put +2 with it. And nitrogen, by now, we should know that it is an anion that will want to gain 3 electrons, so -3. So here we go. We got 2 oxidation numbers that are not the same. So when we write the formula, you want to make sure you use the crisscross method. And so basically, the 2 now goes to the N, and the 3 now goes to the Ca. So when we write it as subscripts, so little baby numbers at the bottom rather than the top of the symbol. And again, the metal goes first. So for calcium, it would be Ca. Now the 3 belongs to Ca, so we're going to put the 3 at the bottom. And then N is next, so we'll write N. And now 2 belongs to the N, so 2. So your final formula here would be Ca3N2. And that's pretty much it. So again, you'll have the rest of class time to finish this entire worksheet. Not entire, excuse me, just page 1. I haven't taught y'all the nomenclature or the naming rules for the other 2, 3, 4 pages, so do not do those. Simply finish page 1. All right? And if you have any questions, we'll discuss it on Monday when I see you again.